Alright guys, I'm going to go through 5.4. We're going to be learning some properties of logarithms. There are three main properties of logarithms that we use. So let's go over those. So the properties of logarithms. Logarithms, something like that. Okay, so the first one, I'll do addition, subtraction, and product. So addition property. So for the addition property of logarithms, if you have a logarithm with some base, we'll say b, of some number, we'll say m, and we're adding that with another logarithm with the same base of some number, we'll say n, this can be written as a logarithm base b of the product of m times by n. I'm just remembering this is not the addition property, this is the product property, not addition. So this is the product property. I'll just say product. So the product property of logarithms. If you have a logarithm with a base b of some number n, and you're adding it with the logarithm with the same base, so they have to be the same, and this is a different number, well, this is equivalent to the logarithm of base b of m times by n. So there's the product right there. Okay, then there's the quotient property. Quotient property, if I have a logarithm of base b of some number n, and I'm subtracting a logarithm with the same base of some number n, this is equal to a logarithm of base b of m divided by n. And then there's the power property of logarithms. If you have a logarithm of some base b of m, and let's say that you're multiplying the log, let's say the logarithm has a coefficient, we'll say something like n. So here we have some coefficient n times by a logarithm with a base b of some number n. Then this is equivalent to a logarithm base b of that same number n being raised to the n power. Okay, so these are the three properties of logarithm. So we're going to use that here on these parts right here. So fill in the missing values to make the equations true. So we have log base 8, log base 8. This one is of 11, this one is of 5. And they're subtracting, so I think we're going to be using this quotient property. Okay, so what do we know? If they're subtracting with the same base, then we can use the quotient. We can use this as one logarithm, and we'll do 11 over 5. So the missing value here would be 11 over 5. So this is called a process of condensing logarithms. So this is a process of condensing logarithm. Condensing logs. It means you take multiple logs, take two or more logs and condense them to one. That's essentially what we're doing right here. We're taking these two logarithms, we're condensing it into one logarithm using the properties of logarithms, but we can only do that with subtraction if they have the same base. And then for this one right here, they're adding, they have the same base, and so what has to be this value right here? So if we're looking at the product property, if we're adding them, you can multiply these numbers. So 11 times by what will give me 44? Well, that's going to be 4. So that will make this equation true. And then for this one right here, this is a power prop. We're going to use a power property because this logarithm has this coefficient right here. It's being multiplied. So what you can do, I'm going to do this in 2 steps before I get the answer, but a lot of times a lot of students just think, well, I can just move this up here to be the power, and that's exactly what we do in this equation right here. We have this n right here. What can I do with it? Well, I can move it up here to be the power of this m right here. So this will be equal to a log with a base 8 of 2 to the 5th. And so that will be equal to a log base 8 of 32. So that would be the number that completes that right there. Okay, so that is condensing logarithms. Now down here, yeah, we're still condensing logarithms, so we're still using the same properties. I think that's going to be the same for 2 and 3. So we got log base, this is the exact same one as this one right here. What in the world? What kind of question banks is this pulling from? All right, that's 11/5. Okay. And then this next one right here, what number does this have to be? So we have an addition right here. So I think we're going to be using the product property. So 5 times by this number should give me 45. So I think that's got to be 9. So that's got to be 9. And then for this one right here, what does this number have to be right here? So if we think about this, you're using the power property with a log base 7, some number squared. So some number, when I square it, should be equal to a log base 7 of 9. So I think this number has to be equal to 3. Cool. Okay, and one last one using the properties. Hopefully we don't get any repeats. So we have a log base 9 of 7 and 4. We're adding them. So that means I can multiply these together. That means this has to be 28 right there. Okay, we have subtraction, 5 and 5. What does this number have to be if I have 9/11ths? That would have to make this part right here 11. And then for this one, okay, so what does the coefficient have to be to make this 1/27th? Remember that this coefficient can be also used as the power. So what power here does this have to be to make this 27? That's going to have to be negative 3. So that's going to be the coefficient there. Okay. Question 4. Use the properties of logarithms to evaluate each of the following expressions. All right, so using the same properties, we have a log base 12 and 12 here. So this is going to be, yeah, we're still condensing the logarithm. So first thing that I'm going to do with this process of condensing is I'm first going to adjust the position of that 2 to be right here, to be the power. So this will be a log with a base 12 of 9 plus log base 12 of 4 squared, which is going to be 16. Okay, now that I have that, now I can use the product property, log with a base of 12 of 9 times 16. So we need to get a calculator. All right, 9 times by 16, it's going to be 144. So this is going to be a log with a base 12 of 144. Okay, and then here, what we can do, we learned this trick in the first or 5.1 or 5.2. So we're trying to evaluate this logarithm. If you remember how to evaluate logarithms, let's rewrite it as an exponential. So I can write this as 12 to some number should give me 144. So that's how we're going to find the value here, is find the value of the exponents, because logs equal exponents. So to what number does this have to be to get that to be that? I think that has to be 2. So this logarithm is going to be equal to 2. That will be the answer for this question right there. For B, okay, we have some natural logarithms, so that means they have the same base. Now, for this one right here, this one should be pretty simple. If you have a natural log is a base e. And so basically what this is saying right here, this is log base e of e to the 7, technically is one way to think about it. So if you have a natural log, and inside the natural log has a base of e, well, those cancel. Now, before they cancel, let's do this right here. So using the properties of logarithms, this 7, and we can use the same thing in this too, we'll bring these down. So bring those down as coefficients. So these properties can work either way. So we're using this power property. However, instead of moving the quotient up here, we're actually taking the power and we're going to bring it down as, sorry, not the quotient, the coefficient. Instead of taking this coefficient and moving it up here, we're going to take this power and move it down as its coefficient. And so here, let's rewrite this as 7 natural log of e minus 2 natural log of e. Well, that ends up just being 1. So this becomes 7 times by 1, which is 7, minus 2 times by 1, which is 2. So this ends up just being equal to 5. Okay? So remember that. So natural log of e is equal to 1. Okay, natural log of e is equal to 1. And then you can use that with any other. So a log with a base b of b is equal to 1. So same thing. All right, use the properties of logarithm to evaluate these expressions right here. So we've got 3 with a log base 3 of 2, and we have a log base 3 of 72. So first thing that I'm going to do is move this 3 up here. So I think that will make that a log base 3 of 2 to the third, which is going to be 8. Then minus a log base 3 of 72. Okay. Now for this one right here, I can divide these right here. So 8 divided by 72. That's gotta simplify, right? So 8 over 72. Let's see, what's 72 divided by 8? It's equal to 9. So this is going to be equal to 1/9. So this right here will be equal to a log with a base 3 of 8 over 72 because it's subtraction. But I'm just going to simplify that 8 over 72 to be 1/9. So 1/9. And then we're trying to see what this will equal. So what is that supposed to equal? Well, remember that logarithms equal exponents. So if I do 3 to some power, what exponent power do I have to do to make this equal to 1/9? Well, that means that's going to have to be equal to -2. So this logarithm is going to be -2. All right, and here, using the power property of logarithms, let's move those right there. So this is 6 natural log of e plus 12 natural log of e. Natural log of e is equal to 1, so this becomes 6 plus 12, so this is going to be equal to 18. Got another one like that for question 6. So, starting with the logarithms here, so this will be equal to 3. First of all, what we're going to do here is move this 2. So this coefficient right here and this coefficient right here. Now there is already a coefficient right here. That means they will multiply. So it's 3 times by 2. So this becomes 6 natural log of e and then minus 12 natural log of e. So when I move this 12 out here, that's going to make that negative. And we know that natural log of e is 1. So this becomes 6 minus 12. That becomes -6. All right, and we got this logarithm here. We're subtracting the logarithm, so 75 divided by 3, we'll use the quotient property since they have the same base. So this will be equal to a log with a base 5 of 25. So what will this be equal to? So 5 logarithms equal exponents, so 5 to what value will be equal to 25. So that means that this is going to be equal to 2. All right, for question 7, use the properties of logarithms to expand. So we talked about condensing logarithms. So these examples up here, we condense them. So I'll do this right here. So I'm going to make a double-sided arrow here. I'll do it like this right here, double-sided arrow. So these properties can be used in 2 ways. They can be used to condense. So condense into one logarithm. Notice that on the right side of these right here, they're condensed into one logarithm. So I'll say this. So one logarithm with, I'll say one logarithm and no coefficients. On the other side, we have logarithms that have been expanded. So this is called expand. So basically what this means for expansion, so you have one logarithm, you can expand them out into multiple logarithms using addition, subtraction, and no powers. So no powers on these values right here. So multiple logarithms, multiple logs, no, we'll say this, no products or quotients, and no powers. So no quotients, no products, and no powers. Multiple logarithms. So we can't have a logarithm that has a product, a quotient, or a power. Okay. Okay. So let's keep that in mind. So here we have a logarithm that has a quotient, and it has this part right here, which has a power. So the way I think about this sometimes, if we simplify anything that you're dividing by, so since we do have a quotient, that tells me that we're going to have a subtraction. So we're going to have a log, we're going to have multiple logs, we're going to have two different logs. So I'm going to separate these two items into two different logs, so log of y to the 6th and log of x, and we're going to subtract them because this is a quotient. And then the last thing I'm going to do, we can't have, so we got rid of this quotient right here, but we also can't have any power. So this one has been reduced or expanded as much as it can. So x, it has no, this right here has no product, it has no quotient, it has no powers. But this one needs to be adjusted, and that just has to do with this power right here. So we're going to use the power property, and we're just going to move this 6 right here. So it's going to be 6 times by that, and then I'm going to remove the power right there. So 6 with a log of y minus a log of x, and that's how you can write your answer. So each logarithm should involve only one variable, okay, and should not have any exponents or fractions. Assume all variables are positive. Don't worry about that part, I guess. Use the properties of logarithms to expand this one. So we have a log. Now this has a product. So we're going to separate this into two different logarithms. So a log of x to the 9 plus a log of y. And then this one still has a power. So I'll just write this as 9 times by log of that. And then I'll erase that right there. So I got 9 log of x plus log of y. Got one more right here for 9. So we have, again, a product. So I'm going to expand this to be log of z plus a log of x to the 3rd. And then I'm going to move that third to be 3 log of x. Okay, and I think that's it for those ones. Okay, for 10, 11, and 12, these ones are going to be more tricky. There's a lot going on right here. Okay, so notice here, oh man, so much going on right here. Okay, you have to be really careful. This is tricky because we have a square root. We also have a product right here and a quotient, and we have power. So there's a lot going on. So first thing you want to keep in mind is that remember that square roots are just powers. So if you have something so if you have the square root of x, that's the same thing as x to the 1/2 power. So I'm going to rewrite this as yz to the 5th, x to the 3rd to the 1/2 power. Okay, that makes things really extra difficult for this one right here. Because of this 1/2 power. So this 1/2 power belongs to everything, if you guys remember how to use those properties of exponents. So we can write this as a log of y to the 1/2 of z to the 5/2 of x to the 3/2, like that right there. Okay. All right. and I just totally skipped 10. I don't know why. We'll come back to that one right there. Don't know why I just totally skipped over that one. All right, and so now what we're going to do here is we are going to expand. So now that I have a product and I have a quotient right here, so this is going to require 3 logarithms. So I'm going to have a log, I'm going to have another log, and I'm going to have another log, because I have 3 variables. I have a y, z, and an x. So this log is going to be y to the 1/2. This one's going to be z to the 5/2, and this one's going to be x to the 3/2. Now, in between them, anything that's in the numerator is going to be addition. So we're going to add them. Now that this is in the denominator, because that's the quotient, that's going to be a subtraction, just like that. So we're subtracting those. And then we have to move these exponents down below, or move them to be coefficients. So let me just move this up. We're going to make room. So this is going to be 1/2 log of y plus 5/2 log of z minus 3/2 log of x. And there you go. So it's not too bad, but it is a lot to kind of keep track of. So let's try 10, going back up to 10 here. Now, anytime I see radicals, remember that the cube root of x is equal to x to the 1/3. So I'm going to start with that one. So log of, now we have x to the, that would make this x to the 5/3, because we already have a 5 here. So 5 and 1/3 is going to be 5/3 right there, over y squared and z. Okay, now whenever I expand this, again, I have an x, a y, and a z, so I'm going to need 3 logarithms. So I'm going to have a log, I'm going to have a log, and I'm going to have a log. I'm going to have a log of x to the 5/3. I'm going to have a log of y squared. I'm going to have a log of z. Now notice that this is the only one in the numerator. So this is the only log that's going to be positive. The other 2 logs with y squared and z, you have to subtract those. So those are going to be negative logs, because they are both in the denominator. All right, and then we're going to move any powers that we have. So 5/3 log of x minus 2 log of y minus log of z. And there you have that one right there. Okay, and we'll do the same thing here. I'm going to first start with that one right there. So we have log, we've got y to the 7th, we've got x, we've got z to the 3/2, because it's a square root, so 1/2. Okay, so I should have 3 logs. So I'm going to have a log of y to the 7th. Now the other logs are going to be subtracted because they're in the denominator. So a log of x, then minus a log of z to the 3/2. I'm just going to move this 3/2 here first. So let me move this slightly to the right and move this 3/2. Oops. I'll just rewrite it. I'll erase it, and I'll make this 3/2 right here. Okay, so that's expansion of logarithms. These ones are definitely more trickier than the ones before, but still very doable. All right, for 13, write an expression as a single logarithm. I have no idea why these bases are so large. So, I'm just going to ignore that right there, because I don't know what it wants me to put where. This is so wacky. Okay, so it wants us to write as a single logarithm. This means condense. So we are going to condense these logarithms. We have multiple logarithms. They have coefficients, so we don't want coefficients. All right, so that's the first thing I'm going to take care of in this one. So I'm going to take this 3, I'm going to put it right here, take the 7, put it right there. That's the first thing I'm going to do. So I'm going to have a log base 7 of z minus 3 to the 3rd minus a log base 7 of z plus 4 to the 7th. And now it's subtraction, so that means I'm going to make a quotient of these 2 items. So we're going to use one single logarithm. It's going to be a log with a base of 7, and then we're going to have a quotient because it's subtraction. So we're going to have a quotient. On the numerator, it's going to be z minus 3 to the 3rd, and then on the denominator, we're going to have z plus 4 to the 7th. I don't know why that's a 2 right there. It should be 7, right? Yeah, 7. Okay, and that's it. That's what you're going to put right here. So I don't know what it wants me. Does it want me to put the base here? And then here would be z minus 3 to the 3rd over z plus 4 to the 7th, maybe? Maybe that's how it wants me to write it. Okay. All right, for this one, now notice where this 6 is right here. So this 6 is tricky. What I would probably do first is I would distribute the 6 to all parts right here. So the 6 to the 4, 6 right here to this logarithm, and then 6 to this 1/12. So that's probably how I would tackle anything like that right there. So this would be 24 with a log base 5 of z minus 6 log base 5 of y, then plus 1/2, because 6 times 1/12 is 1/2, log base 5 of w. Then I would deal with these coefficients right here, all these coefficients. I'd probably deal with those next. So log base 5 of z to the 24th minus the log base 5 of y to the 6th, and then plus log base 5 of, what does it want me to do with that w? That w right there. I'll say w to the 1/2. I don't know if it wants me to write that as a square root. You could probably do either, but I'm going to say just 1/2 right here. Okay, now I do have 3 different logarithms. We're trying to condense it into a single logarithm. So we just want a log with a base 5. Now we are going to have quotients in here and products. So we're going to write this as a single logarithm with quotients and products. So whenever you have a logarithm that is negative, so we've got this negative right here. So any log with that's negative, that's going to be, this part is going to go in the denominator. So y to the 6. Any logarithm that's positive, you're going to write that term in the numerator. So that's going to be z to the 24th times by w to the 1/2. And that should be good right there. So we have a single logarithm, no coefficients. All of these variables have their powers and they're in the correct spot. So again, how do you know if they're numerator or denominator? If the logarithm is negative, that's the denominator. If the logarithm is positive, it's in the numerator. Okay, for 15, I'm going to deal with this part first right here, this 4 that's hanging out right here. In the same way that this 6 up here was hanging out for all 3. So I'm going to distribute that 4. So distribute the 4 here. Distribute the 4 here. So I'm going to get a 3 with a log base m of y plus 4 with the log base m of z minus 16 log with a base m of x. And then I'm going to deal with all these coefficients, so the 3, the 4, and the 16. I'll do those next. So log base m of y to the 3rd plus a log base m of z to the 4th minus a log base m of x to the 16th. And then condense it all into one logarithm. So log with a base m, it looks like we are going to have, if I see something that's negative, then I'm going to make a quotient, because that means we're going to have something in the denominator, and that x to the 16th is going to be in the denominator, while the y to the 3rd and the z to the 4th are going to be in the numerator. Okay. And then for, I think we're done with those types. 16, 17, and 18. These are all calculators. So change of base formula. Change of base formula is using a calculator pretty much. So use calculator. I'll show you guys how to use Desmos. So the change of base formula. So I told you guys earlier, whenever we were first evaluating, well, this is kind of funny because if you have Desmos, then you don't need to use the change of base formula, but whatever. Basically, what we're trying to do is we're trying to evaluate these in our calculators. Now, most calculators, scientific calculators, and basic scientific calculators are only going to have 2 logarithms, a common logarithm, so the common logarithm, and the natural logarithm. So the common logarithm has a base of 10. A natural logarithm is a base e. So common logarithm is base 10. A natural logarithm is base e. Natural logarithm is base e. So those are typically the only 2 logarithms that you can evaluate in your calculator. On basic scientific calculators, that is. There are other calculators that can evaluate all logarithms. So like this one right here. So this one has a base of 1/9. So those two buttons in your calculator won't work. So that's where this change of base formula comes in. So the change of base formula just says this right here. So we have a log of 1/9 of 8. You can evaluate this in your calculator. What we can do is we can convert this to common logarithms or natural logarithms or any log that we want. That's why we call it the change of base formula. But essentially, we can put this in our calculators as log of 8 over log of 1/9. Now, this does not matter. So if you type this into your calculator, it does not matter if you use a logarithm of base 10 or a natural logarithm. So you can even in your calculator type this in as natural log of 8 over the natural log of 1/9, and you'll still get the same thing. It doesn't matter what base this logarithm is. If you take the logarithm of 8 divided by the logarithm of that base right there, they're all going to be the same thing. So let me show you. I'll go ahead and put this into Desmos. So I'll open up Desmos. So first of all, in Desmos, you can actually just type in the base. So if you could do log, now on the bottom row of this keyboard right here, on the far left next to the right of the 120 of the 123, you can add a subscript in here. So it was of 1/9. So 1 divided by 9, and then make sure that you click out, or maybe you use your arrows. So push the right arrow, and then we can put 8 right there, and that's the value of log base 1/9 of 8. Now, in your calculator that you're going to have for the test and in class right here, again, I told you that you can actually change this to it's a quotient of whatever logarithm you want. So I'm going to do a log of 8. Just make sure that the 8 goes on the numerator. So log of 8, then I'm going to divide this by a common logarithm of 1/9. So 1 divided by 9. And you see that we get the same thing. And I can even change it to be, I can use natural log. So natural log of 8 divided by natural log of 1 divided by 9. And you still get the same thing. So this is called the change of base formula. Pretty much it just allows us to evaluate logarithms of any base any way that we want, kind of essentially. It's actually a really unique formula, really cool. So in any case, so this right here ends up being equal to, we're going to round to the nearest thousandth, so negative 0.946. Okay, for the next one, we have log base 3 of 4. So if you go into Desmos, try to use the base. I know that you can use, you don't have to use the change of base formula in Desmos, but practice this for the test so that you don't get mixed up on what goes on the numerator, what goes on the denominator. So this, whenever I type this into my calculator, it's log of 4. So log of 4 goes on top, log of 3 goes on the denominator. So we'll do that. So, and I usually just do natural log. Honestly, I just use natural log. So natural log of 4 divided by the natural log of 3. And I get 1.262. So this is equal to 1.262. Okay, and then for this one right here, this will be equal to log of 8 divided by log of 5. So in your calculator, we can do that. I'll do log this time. So log of 8 divided by log of 2. Log of 8 divided by log of 2. Log of 5. I was going to say that didn't sound right. That sounded too even of a number. Log of 5. So 1.292. I just kind of show you just again that you can use any base that you want. I can still do the natural log if you chose to use natural log of 8 divided by the natural log of 5. Still get the same thing, 1.292. So this will be equal to 1.292. Okay, and that should do it for 5.4.